Um, Again, also today, I welcome all participants in the hall here, and I know that there are more on the Zoom application. So hello, at the beginning of the section 4 of the meeting, the challenges of the modeling and analysis in the LULUCF sector. So what to say about LULUCF sector? It is important sector for land use changes, forest, and also partly wood processing industry and wood flow in between forest and wood processing industry. And there is a question, because forests could be, or it is one of the biggest sinks of the CO2. So what is the role in nature, and what is the role in all kind of commitments which we undersign and participate as different parties? So on one side we have some natural processes which are very complex, and in the time of the climate change is very it's a huge variety of the sink strength of the forest, for example, but we have also land use which is changing during the time, and also that means additional emissions or additional sink of the green gases. So, and one question is how to know and how to see the future of these emissions, what we need to do to prognose and to have a tool for policy to make some decisions in policy. So one and the most powerful tool is modeling, but for modeling we need good data sets. So today's session will be focused on the challenges of the modeling and analysis, and partly will be also be dedicated to the data, and which are in forestry are, let's say, NFIs or national forestry inventories. So we will have 3 speakers: Dr. Roberto Pilli, Dr. Thomas Ledermann, and Dr. Boštjan Mali. They will present their presentation. After that will be a coffee break and then round table discussion with questions which are already, some are prepared and some will be, I hope, that the colleagues and participants they will ask, and our roundtable panelists with interesting questions. And I hope that we will get also more information about modeling and possibility of models to predict what will happen in LULUCF sector in next 30 years. So first I invite Roberto Pilli for speak about forest modeling within the LULUCF sector, new challenges and opportunities. Roberto Pilli, he holds a PhD in forest ecology at University Padova in 2007, and a bachelor degree in history at the same university in 2015. He currently collaborates as freelance with the Joint Research Center of the European Commission, where he was also employed as scientific officer until 2020. He mostly worked on forest modeling for assessing the forest biomass and carbon mitigation potential, both at European and at national scale. So, if we have connection with Roberto, please.
Yes, thanks, and thanks for the nice presentation and the nice introduction that perfectly, say, perfectly in line with the topic of my presentation. So I will immediately go to share the screen. Hopefully you can see my presentation. Yes, okay, thanks. So topic of my presentation will be on forest modeling within the LULUCF sector, new challenges and opportunities, and is, I would say, perfectly in line with what you, with your introduction. So on this year, on the 14th July 2021, the European Commission presented its new Fit for 55 climate package, which is part of the European Green Deal. The overall objective of this package, we know, is reducing EU net greenhouse gas emissions by at least 55% by 2030 compared to 1990, and possibly to become carbon neutral by 2050. New forest strategies, such as a revised regulation of this sector, the LULUCF sector, as well as the EU biodiversity strategy, are all complementary pillars of these ambitious objectives. However, as you told, to become climate neutral by 2050, on top of a drastic decarbonization of energy, transport, and industrial sector, the EU net sink from forest land should increase to about minus 450 million tons of CO2 per year by 2050. Considering the recent evolution of the EU, the overall EU forest carbon sink, which is declining in the last year from about minus 400 in the period 2010-2030 to about minus 360 in the last years, reaching this target requires additional efforts to, let's say, to the forest sector. And these efforts should be based on somehow a strategic view of the expected evolution of our forest within the next decades. So modeling this evolution is challenging. Which is, let's say, the place, the role of the forest sector within the LULUCF sector. You see here, this is the LULUCF sector highlighted by this green line, which includes not only the forest ecosystems, but also non-forest land uses, cropland, grassland, and so on. Here we have, let's say, our forest ecosystems that from, let's say, a carbon accounting perspective include the traditional 5 carbon pools, living biomass, dead organic matter, and soils. But within the forest sector, we also need to consider harvested wood products that are this, let's say, 6 pool that is stored outside from forest, but is nevertheless quite important because through this pool, the forest sectors also interact with other sectors, because we know that harvested wood products can be used to substitute other materials that are generally more greenhouse gas intensive, let's say, such as concrete, for example, but can be also used wood to produce energy instead of fossil fuels. So assessing the role of forest-based bioeconomy in mitigating climate change requires, let's say, a system perspective where we need to consider all these possible interactions, increasing carbon stock within the forest land and or in harvested wood products. Harvested wood products can be used to substitute other materials and or to substitute fossil fuels. So you already understand that this is really complex. but which is, let's say, which can be our attitude as forest modelers, as forest managers, or also as, let's say, stakeholders or decision makers in front of this complex system. Here I report this interesting, from my point of view, figure from this paper, where we see that we have different possibilities. We can place ourselves, let's say, from different perspectives in front of climate change, from as a foresters, I would say. We may have this, let's say, non-adaptative approach, where we have no change decision. So this means that past treatments will continue and will be repeated as long as they appear to work. We continue with our traditional forest management independently from the effect of climate change. Another possible approach is to have this reactive decision making, where decisions are changed but based on the observed change in the past. So we react in front of climate change, but after that we see determining effect. Otherwise, we may have a more proactive, let's say, attitude approach in front of climate change. This is represented from this trend adaptative green line, where adaptation, we try to adapt our forest management to predict a determined trend. And finally, we may have a forward-looking adaptative decision making. You see here this proactive forward-looking blue line, including a range of possible future management options, but where expectations get broader and even more uncertain. So which can be our attitude, our approach. This depends a lot also by our management choices and by our modeling capacities. So this is quite challenging. So you understand that this is quite challenging. And then from one side, let's say we need to continue with our short-term forest management tools, looking for the short-term evolution of the forest carbon sink and biomass as is determined from forest management activities and when occurring from natural disturbances. Just think to salvage logging. Assessing the impact of forest management practices on the future forest carbon sink, even in the short term, can be quite challenging because of the uncertainty linked to policy and economic drivers that we know may directly affect the future harvest rate, even within the short term. Just think to the effect that, let's say, big windstorms or bark beetle attacks can have on the market. On the other side, when speaking about the role of forest ecosystem within climate change, we need to have a long-term perspective. Here, we aim to investigate the long-term evolution of the forest carbon sink that is linked to the complex interactions between climatic variables, temperature, precipitation, CO2 concentration, and forest ecosystem. Due to the uncertainty on the future evolution of climate change and the relative impact of this variable on forest growth, of course, we need to assess these aspects combining different climatic scenarios. For this reason, we may have that various studies, even if maybe not accounting for the additional effect of climate change and therefore considering only the short-term evolution of the forest carbon sink, different studies may provide different and sometimes opposite results. So, for example, here I report a couple of studies, one from Nabourse, where the authors estimated that the U28 forest carbon sink could potentially increase by about 172 million tons of CO2 per year by 2050. On the opposite, this other study from Johnson et al., based on different methodological assumptions and harvest scenarios, estimated a reduction of the U28 forest carbon sink between minus 50 and minus 180 million tons of CO2 per year in 2030 compared to 2050. So apparently an opposite results. This difference can be further amplified when empirical models, the models that we traditionally use, let's say within our forest management plans, are applied within long-term scenario analysis. Indeed, even assuming the same harvest level, similar model may produce different results, for example, because of different assumptions on management strategies applied at the local level, which may in turn also affect the evolution of the age class distribution. But also, let's say, determining a common, possibly neutral management scenario, so a sort of business as usual, representing a benchmark for developing the future management strategies, can be quite challenging. So at the end, we need, let's say, to provide some compromise solution. This is, I would say, the only choice. The forest carbon sink, as we told, is mostly affected from the actual and past management practices. This determines the forest composition, the age structure, and this is influenced at the local level from economic drivers and stochastic events such as disturbance events. For modeling the medium and the short-term evolution of these variables, for sure, empirical forest and growth models are generally best suited. However, these models simulating the forest growth based on past observation cannot easily determine the possible distortions on the future due to climate changes, which can modify the current vegetation growth rate. On the other side, the long-term evolution of the forest carbon sink is determined from climatic change conditions and long-term management strategies, which may affect forest composition, age structure, and so on. For modeling this long-term evolution, the long-term evolution of these variables, and even the large-scale management strategies, process-based climate models are best suited. However, these models mostly are grounded on ecological theories and generally means to consider detailed information on management practices and forest conditions as determined from direct field measurements. So this means that we need to have a compromise solution that is building a sort of meta-modeling framework where we merge together the strategic information provided from process-based model with the tactical, I would say, accuracy provided from empirical models. But this approach also requires to balance different and partially opposite methodological assumptions. So then, which is, let's say, the compass that we may use to find the core direction for our forest management. We thought from one side, we certainly need to use inventory-based model, which simulate the short-term evolution of forest carbon sink under different forest management activities based on past observations. Then we need to consider also the contribution of process-based models, which focus on climatic variables, such as temperature and biogeochemical process. This enables to simulate the forest responses to variations in climatic and environmental conditions. But this is not enough, I would say, because we also need, let's say, to consider the forest and dynamics in relation to the overall forest landscape process. So let's say in especially, as much as possible, in especially explicit framework. For this reason, we also need to use forest landscape models. However, these models typically simplify the sidescape processes, so they need to be somehow merged with the inventory-based model. Again, this is not enough, because we just told that we also need to consider the economic drivers that at the end affect our concrete forest management within the short period. So we also need to, within our modeling framework, to consider forest economic models that derive projections for the consumption, production, and trade of wood based on products under different scenarios. So we already, let's say, have at least four different tools. But again, I would say this is not enough because of natural disturbances. We know very well, we have a concrete experience every day now, unfortunately, of the effect of natural disturbances. And we already know that we will have an increasing impact of natural disturbances. So even modeling, specifically modeling the impact of natural disturbances is absolutely needed. And last but not least, We do not have to forget that our forests also have a multifunctional, are part of a multifunctional system. So we cannot forget the other functions provided by forests, not only, of course, the climate mitigation or the production, but also recreational function, biodiversity, and so on. So at the end, we also need to consider multifunctional forest management tools. So all these, let's say, approaches need to be merged together within this meta modeling framework. But for this, let's say, to provide this meta modeling framework, we also need to have concrete data. Here I report, let's say, just a part of the EU forest strategy, where is clearly highlighted that today the information concerning the status of forests in the EU and in single countries are patchy. There are challenges related to the use of remote sensing that need to be merged with the ground-based, so with the traditional NFI information. Still, we have an insufficient planning for the forest, so we should focus on regular and more frequent cost-efficient reporting and update data. Monitoring also has to be done with high spatial resolution as much as possible, of course, and this is quite important. So to conclude, to have this strategic forest monitoring approach, we need also to collect information on harvest level and removals of woody biomass at EU and at country level that in some cases are still highly uncertain. We need to have tools to provide special prediction of forest variables that are required for supporting modern national and subnational forest planning strategies, especially in the framework of climate change. NFI should or could evolve in a permanent monitoring system where a sample of the total number of field plots, for example, is visited in the field every year. And finally, traditional NFI plot data should be merged as much as possible with remote sensing technology and auxiliary variables. This is quite essential. So again, maintaining or enhancing the current forest mitigation potential we see is challenging. And this urgently requires alternative management strategies and new modeling tools. Merging traditional scientific objectives generally linked to climate change perspective, I would say, with more pragmatic, more practical application strictly linked to forest management and planning activities. So this means that we need also somehow to downscale our tools from a global to a country, to a regional, and really to a local level. This one, I conclude my presentation. Thanks.
Yeah, thank you for your presentation, Roberto. It was really a great introduction to today's meeting thema. So first, I will look if somebody has any question in the room. Is there any question? Okay. If not, then maybe somebody from the audience on Zoom. I'm looking for hands, if there's somebody who will. Anyway, if not, yeah, we started maybe in the morning, and morning first session is a little bit still warming the temperature of everybody, but anyway, we will have a roundtable. So we will use roundtable to ask you and your colleagues also maybe about about your presentation. For me, it's interesting what you show us. For example, this article in Nature, and then opposite from Finnish and Scandinavian colleagues about is the forest and to what extent will be a sink or not a sink in next period. This was quite challenging because it shows us that also scientific teams which prepare this articles or theses, these numbers, they have different opinions, and because they use different methods to. Maybe you could just explain a little bit about that.
Yes. Yes, it's.
Yeah, please.
Yeah, no, yes, is yeah, that's what let's say. I was trying to very shortly to highlight that we may have, let's say, apparently opposite results, but because, let's say, the background assumptions maybe are quite different, and why they are different is also because of the uncertainty on, let's say, the future development of the sector, since it is quite complex. So just thinking to the effect of climate change, we may have different models providing quite different signals, I would say. This doesn't mean that, of course, one of these models is, let's say, wrong and the other one is correct, but it's simply related to the uncertainty on the future development and the future impact of climate change. And the same is even, I would say, even more when we are going to consider, let's say, economic drivers, because you certainly know that, let's say, the evolution of the market is, let's say, also quite uncertain. So every time we are going to consider within our model some the effect, the possible evolution of the market, this introduces some uncertainty. So simply taking different assumptions, we may have different results, independently from the fact that maybe that the model starts exactly from the same, let's say, level, I would say. And even it's apparently is, let's say, strange, but even assuming a common, identifying a common baseline, a common benchmark can be challenging. Sometimes you need, let's say, really to discuss in detail, okay, which would be the common baseline, and then we can compare different scenarios with a common baseline. But defining a common baseline for the future means, okay, which would be the evolution within a business as usual scenario of our forest management system, of our forest sink. Unfortunately, forests are not, or I don't know if it is unfortunate is the correct word, but anyway, forests are not like, let's say, an industry where we can say, okay, industry will continue to produce at the same levels, or emissions will be continue to be the same, because forests are getting older or are getting younger, depending from our forest management. And we know very well that this affects also our increment, our sink, and so on. So this makes really modeling the evolution of the forest carbon budget more complex and more difficult.
Yeah, thanks, Roberto. Boštjan Mali, he has a question. Could you give us a mic?
Hello, Roberto. Thank you very much for the nice presentation and the really good overview of the modeling approaches in forestry. I would like to ask, you showed us also the goal for, let's say, 2030, but what can you say about 2050? If we want to approach climate neutrality, so net zero, let's say the Commission also show us on different occasions and events, you know, the projections, how carbon sinks from the LULUCF sector can be enhanced. So, of course, in 2050, there will be still emissions from industry, transportation, and so on. So we have to compensate these emissions somehow with removals. We know that, let's say, improved technologies such as carbon storage and capture will come, let's say, later on, let's say, after 2035 or something like that. And can you say that we can enhance or improve carbon sink largely in long term? Because as you said, let's say, yes, if we had old forests, yes, there is huge sink, but maybe we also approach the saturation point, and we have to regenerate forests. So I will also, in my presentation at the end, about the perspective, upon this, because the time frames are really the question mark. So what's your opinion? Is this achievable, that we can increase the sink in long term instantly, or this really depends on time frames? That will be my question. Thanks.
Yeah, thanks. I can only be, let's say, can only agree with you. It's even more challenging because, let's say, it's I was speaking about a short-term perspective and a long-term perspective, but in reality, as foresters, we know that long-term means, in this case, we are speaking about 30 years. This is not, let's say, a long-term perspective from, if we look to the evolution of our forest, because we can just think to, let's say, the normal period of evolution of our forest. I'm thinking to beech or spruce. So it's not really, let's say, a long-term perspective. So I started my presentation, highlighted this decreasing carbon sink that is reported from most or all European countries. So reversing this trend is even more challenging, even if we speak about 2050 instead of 2030. Is certainly challenging. And that's why we need to, let's say, urgently need, I would say, to refine our modeling approach, to verify, I would say, to see if it is really possible. Of course, there is some objective that was, let's say, proposed from the Commission, and here forests have a key role because they need to compensate these unavoidable emissions that we will continue to have from industry and from other sectors. But is it, let's say, concretely possible to have this forest carbon sink, looking to our forest management system and so on? Because we are speaking about a period that is quite short. So really, we need to verify, urgently verify, if this is possible. So let's say I don't have an answer, a clear answer, but I agree. I think we are perfectly in line with. I agree with you. It is difficult, and we really need to see in detail. I'm not saying a local level, but at regional level, how our forests are evolving based on the age structure, based on the forest management, and based on the possible impact of climate change and disturbances, to see which we may also have, let's say, different strategies that need to be downscaled at local level. So maybe that for one region and for a certain, let's say, forest species, the best choice is to, let's say, improve the forest carbon sink as it is, while for other regions, we may, let's say, improve the harvested wood products mitigation potential. And even there, of course, we need to find a balance between different possible uses of these products. So this is something that really needed to be calibrated, I would say, based on the local conditions.
Okay, thank you both. So we need to ask Dr. Thomas Ledermann for next presentation. So the title of presentation is Using National Forest Inventory Data and Tree Growth Model to Evaluate the Effects of Climate Change and Climate Change Adaptation on the greenhouse gases balance of Austrian forest-based sector. Dr. Thomas Ledermann, he is a senior scientist, Department of Forest Growth, Silviculture and Genetics at Austrian Research Center for Forest is his working place. So he graduated from Boku University in Vienna. He holds PhD in forestry and habilitation in forest biometrics and growth modeling. Currently, he is working as senior scientist at the Austrian Research Center, and he is concerning with the development of individual tree growth models, projections of forest resources, as well as long-term growth experiments. He was involved in 2 studies on CO2 emissions of the Austrian wood utilization chain and did the simulation runs with the forest growth model CalDIS to set up the forest reference level in Austria. As you know, forest reference level is used now for next 5 years period as basic information about forest sinks or emissions for member states. So please, Thomas, the floor is yours.
Thank you for this nice introduction. Now I will try to share my screen. So can you see my screen?
Yeah.
Okay, fine. Yes, ladies and gentlemen, I'm really happy that I'm allowed to present here the results of a study that we performed within the last 3 years. I will mainly focus on the part which refers to the development of the Austrian forests. This study focused on the evaluation of the effects of climate change and climate change adaptation measures on the greenhouse gas balance of Austria's forest-based sector. This was a study which was done in close collaboration with Boku University, which was responsible for the modeling of the harvested wood products, and also with the environmental agency in Vienna, which was in charge of the modeling of the avoided CO2 emissions. So what was the basis for our study? This was the Austrian data of the Austrian National Forest Inventory. We have a long history on such inventories because since the 1960s we have already sample plots located all over the country. We have to consider the first 2 periods from 1960 to 70 and from 70 to 1980. These were only temporary sample plots, but at the beginning of the 1980s in Austria there were installed permanent sample plots, and the last full inventory was then run in the years 2007 to 2009. These data from 1980 to 2009 served in 2 ways for our modeling. Because all the growth functions and all other submodels of the CalDIS model were derived from these data. And on the other hand, the most recent NFI data from 2007 to 2009 served as the basis for starting our simulation runs for this mentioned project. This is a picture of a typical sample plot of the Austrian National Forest Inventory. We have a small fixed radius sample plot with a radius of 2.6 meters, where trees from 5 centimeters to 10.4 centimeters are collected and they are measured. All the tree characteristics of these trees are measured. And for trees larger than 10.4 centimeters in diameter at breast height, we use the Bitterlich sampling method with a basal error factor of 4 square meters per hectare to collect sample trees. And there's an additional fixed radius sample plot with a radius of 9.77 meters. And on this large sample plot, all the site characteristics are assessed, such as site elevation, soil type, vegetation type, and so on. All these variables are then used as input variables for our growth model. The CalDIS model is a model which follows the FVS type. So it's similar, or it uses it's based on the concept of the forest vegetation simulator, which was formerly known as the prognosis model for stand development, which was developed in the 1970s by Stage. During the 1990s, this concept was transferred to Austria, and at Boku University, the Prognos model was developed by Monsrud and Sterber and Hasnauer. And CALDIS now is a climate. We have to consider that Prognos was not climate sensitive at this stage. And the CALDIS model was then made climate sensitive because 3 of the main components of the model use precipitation and mean temperature, and 1, the disturbance model, also uses wind speed. So we have some, although this is basically an empirical model developed from NFI data, we try to make it climate sensitive that we can also perform long-term studies. This is a typical the development of diameter growth of a Norway spruce tree in dependence of temperature sum and precipitation. And on the right-hand side, you can see the basic concept. This model, this empirical model, is a log linear model which estimates the basal area increment of each individual tree and uses size variables such as DBH and crown ratio as predictors, also competition measures and site descriptors, as I mentioned before. And at the last, we have included this precipitation and temperature in these growth functions. The biomass estimation is, so yeah, using this CALDIS model, the growth and development of each individual tree is projected. And then from these 3 characteristics, biomass is estimated via specific biomass equations that are also used for the Austrian greenhouse gas inventory. So from stem volume, we convert stem volume to biomass and then estimate branch and needle mass and also root biomass to get the full estimate of biomass of an individual tree. This model, this growth model, was coupled with a soil carbon model, with the soil carbon model YASO, which was adapted for Austrian conditions by a colleague of mine. And the input for YASO, which is the carbon input, comes from the litter fall from the growth model. And also the climate data which are needed for the YASO model come from the same database as which is used by the CALDIS model. And YASO provides a trend of litter and soil carbon stocks. So with these 2 models, we have more or less covered the system in the forest. Now I will come to this specific project that we have performed, or this analysis that we have performed within the last 3 years. We tried to analyze the effects of climate change and climate change adaptation on the greenhouse balance. And for this purpose, we formulated 6 scenarios of forest management and/or climate change. Then we set up the CALDIS model on the most recent data of the National Forest Inventory, and we estimated the development of each individual sample tree using this stand and site information from the NFI plots. And all the projected tree characteristics were then scaled up to the plot level and further on to the country level using the routine procedures of the Austrian National Forest Inventory. This is an overview of the 6 scenarios that we have formulated. We had 3 scenarios where forest management was not changed but followed a business as usual management scenario. Here at this stage, there are also involved the colleagues, or were involved the colleagues from Boku University, who provided us with the estimation of a forest sector model, where they estimated the potential harvesting amount dependent on the development of different economic characteristics like gross domestic product and so on. And this estimated potential harvesting amount was then transferred to the Caldis model. And in the Caldis model, we tried to get this harvesting amount out of the Austrian forests, considering different constrictions like Forest Act and soil characteristics and other silvicultural restrictions. The business as usual scenario was simulated once with the climate scenario RCP 4.5 and also with the climate scenario RCP 8.5. And then we formulated another scenario which should focus on increased disturbances. In this case, we enhanced the wind speeds and reduced the annual precipitation of the RCP 8.5 climate scenario to get an even more severe climate scenario. But the potential harvesting amount was the same and came from this forest sector model. And then we had 3 other scenarios where in one scenario the rotation cycles were reduced, because this is one measure forest owners are focusing, because if the old growth stands become too high, then they become more susceptible to wind throw. And so forest owners try to harvest these stands earlier. And if we wanted to know what is the effect on the greenhouse balance if this is the preferred management scenario. Another scenario was characterized by a shift to broadleaf tree species. In this case, if a sample plot was harvested, and it was, for example, stocked by coniferous trees, then in the next rotation cycle, we replanted this plot for the next rotation cycle by broadleaf trees, depending on the expected mean temperature. So this is also a measure which is very common in Austria. There are also it is also supported by subsidies, by federal subsidies, to convert susceptible coniferous forest stands to stands comprised of broadleaf tree species. And then the last scenario was a scenario where we reduced the business as usual harvesting amounts by about 25% in order to increase the growing stock in the forests. And we simulated all these 6 scenarios for 140 years. So that means from 2010 to 2150. And all the scenarios were assumed to have this, were combined with this climate change scenario RCP 8.5, except the business as usual, which was also calculated with 4.5. And here you can see the first results. This is the annual cut for the Austrian forests. You can see that these 2 business as usual scenario are more or less stable, around 20 million cubic meters per year. Also close to that harvesting amount is the amount of the increased disturbances. Only at the end of this simulation period, it decreased slightly. On the other hand, we can see if we shorten the rotation cycles, we have a huge amount of harvesting at the very beginning of the simulation period, but then decreases slowly. And on the other hand, if we reduce the harvesting amount by about 25%, this is this green line here. Interesting is the point, the blue line, which is the shift to broadleaf tree species. For a long time, it is more or less similar to the business as usual harvesting amount, but then rapidly drops to about 10 million cubic meters per year. This is due to the fact that as long as coniferous trees are available, forest industry uses these coniferous trees, and then coniferous trees are not available anymore, but cannot be directly replaced by broadleaf tree species. So we did not assume a shift in root processing technology. And this is an indication if this is further pronounced, this management strategy, then wood processing industry has to change their technology, because otherwise in Austria there would be too few, too small amount of coniferous trees in the future. What are the effects on growing stock? Here, most obvious, if we increase, if we reduce the harvesting amount, then the growing stock increases, but to about 550 cubic meters per hectare. But we can see this is more or less the saturation point. Then at about 550 cubic meters per hectare, it starts to decrease. On the other hand, there is a sharp decrease when we shorten the rotation cycles, but then gets stable at about 200 cubic meters per hectare. And if we take a look at the blue line, here we can see that this growing stock decreases slightly, but then there's a turnaround and the growing stock increases. This is due to the fact that these broadleaf tree species are not fully used by wood processing industry. If we convert this to carbon stock and also include the soil carbon, then the curves look similar to that what we saw before. The highest carbon stock is reached by when we increase growing stock, of course. But we can also see that this business as usual scenario with the moderate climate change scenario is more or less close to this shift with to the broadleaf tree species and gets stabilized more or less. All the others reach this point, the highest point at the time of about in the year 2080, 2090, and then the carbon stock in forests start to decrease again. And if we look at this annual change in carbon stock, what is similar, what is also called a sink or a source, then we can say that except for this scenario, shorter rotation cycles, and except for this increasing growing stock, the carbon sink is more or less stable until the year 2070, and then sharply increases and turns to a source. But we can also see that more or less every scenario is getting a source at the end of the simulation period, with one exception. This is the business as usual with the moderate climate scenario, which is more or less plus minus zero. So here I come now to my last slide, which shows you the accumulated sink or sources and also includes the harvested wood products and the avoided CO2 emissions. This is the overall result of this study because, as I mentioned before, I focused on forest development. And here, this is an overall result. And it's interesting that the avoided 2 emissions avoided by the harvested wood products is by far the highest sink in this case. It's similar for 4 scenarios where we have where we have enough wood for producing these harvested wood products. In the broadleaf tree species and also in the increasing growing stock scenario, these avoided CO2 emissions are lower by about 200,000 kilotons CO2. But if we take a look at the overall result, we see that increasing growing stock shows the best overall result, but this lower harvesting amount means also lower avoided emissions. So, and these 200,000 kilotons CO2 are additional emissions from fossil resources. And this is the point, what we are always talking about. This is additional fossil carbon that gets back into the atmosphere. All the other is stored in forest soils, and or harvested wood products, which will be then can get back in atmosphere. But there is a close link to to the wood storage in the forest and also to the carbon store in the atmosphere. So what we also learned is it is very important to get these climate change scenarios, that we should take all measures that climate change scenario will not become as severe as it is projected by this RCP 8.5 scenario, because this will also be provide further wood growing conditions, as we can see this in the first part of this graph, and this is more or less the end of my presentations, and I thank you very much for your attention.
Thank you, Thomas, for your presentation. It was very clear to us, presented what does it mean, different kind of, let's say, adaptation, forest management, how influence on the carbon storage in the forest. Of course, first I will look in the room if there is any question from colleagues here. And I will also check the colleagues, participants, Zoom participants. So I'm looking, is there any hand? Not yet, so probably it will be in a round table some more questions. Anyway, as I see, it's if I understand, one message from your presentation is also to wood processing industry, that they should think about how to include broadleaves in process, broadleaf wood. So is it such message, or what do you think, Thomas, about that?
Yeah, this is what we try to transfer to this wood processing industry, because as long as there is enough amount of coniferous trees, then they rely on that but only through these long-term projections, this became obvious that there is one point in time where the wood processing industry has to change, has to find new technologies to also use wood of broadleaf tree species. I know in Germany there are some projects which try to use beech for construction, but this effort, I think, must be enhanced. These efforts must be enhanced, and we tried to give the wood processing industry some time frame to see how long do they have time for this transferring process.
Yeah. So so there's one question in chat. So it's the question is about in the short rotation scenario, why does the forest become a source so soon?
This is due to the fact that this we said that the mean age of harvesting is now about 100 years. So this is a mean over all stands in Austria, and we reduced that to 75 years. And this sharp reduction leads to a tremendous decrease in the growing stock. And this is the case that this forests become a source so soon.
My question is just a short, because we are a little bit behind the schedule. And the rotation period. So how actively will be a part of forest management practice in Austria if we take in account the climate changes and the disturbances which are present and will be present in future? How active, is it already a part, or it will be a part of the forest management plans in future?
I'm sure it will be part of the forest management plans, because there's a big discussion. Because as we learned in the last, even this year, that we have heavy storms, we know that all these old growth stands become more or less become really susceptible to wind throw. And so this is a big discussion how to deal or how to avoid these big calamities. And one thing is to prefer really strong harvesting, that the diameter increment is sharply increased, and that the forest trees reach dimensions which can be sold on the market much earlier than if you wait for a longer time. Yeah, and if you make this strong harvesting, then these dimensions are reached before the stand height reaches a susceptible height. Yeah, because what we also found is that there is some sort of a critical stand height from which on this probability that the stand is thrown or blown by wind increases rapidly. Yeah, and so we are discussing this with forest managers, and they understand that, and they are more or less willing to do that. But on the other hand, as we see, it's not the best solution for storing of our greenhouse gas balance. Yeah, because here we can see that, as I have shown, that this is that the forest in Austria become a source very soon.
Yeah, thank you, Thomas, for now. We will see in next part of today's sessions. So now I would like to invite Boštjan Mali from the Slovenian Forestry Institute. So title of his presentation is just to find results of the project LIFE ClimatePath2050 and perspectives for modeling forest carbon sinks in Slovenia. Robert, he's my co-worker for many years, so it's always hard to present somebody with who I'm working, but he has also PhD degree in forestry. He studied at Biotechnical Faculty at University Ljubljana. He continued his education at the same university and received his PhD from the interdisciplinary study program, Environmental Protection. He has been employed at the Slovenian Forestry Institute since 2007, and currently he is a research associate in the Department of Forest and Landscape Planning and Monitoring. His work is mainly concerned with the estimation of emissions and removals from land use change and forestry, including projections using models. So Boštjan is involved in the preparation of the National Forestry Accounting Plan, the National Energy and Climate Plan, and Slovenia's long-term climate strategy until 2050. Boštjan, please, the floor is yours.
Hello for all participants here in the hall and also online. So I will present some results from the projects, and also in the last section I will talk some things about the perspectives, what are the major factors. So for all those participants who are not very familiar, okay, we can say a few words about the LULUCF sector. So the LULUCF sector is a bit unique compared to other sectors because we have let's say different categories, different carbon pools and different gases, and of course it's different compared to other sectors because here are not only emissions but also removals. The sector is quite complex because we have to deal with the natural ecosystems, which are difficult, of course, for modeling because the uncertainty is higher, I would say, than in other sectors. We have also, we can say, how is the expression, the permanence or non-permanence, also the legacy effect. So this means what happens in the past, let's say the forest management decisions or, I don't know, natural disturbances affects the situation in forests now and also a few decades later. So a brief overview about the modeling of forest growth in Slovenia. I can say that in Slovenia we don't have large past experience with the forest modeling. You can see that, let's say, the first published paper was really, I can say, a few years ago. This was the first data mining approach. Of course, we have some modeling approaches, but this was more or less how the species composition will change in the future, but not the forest growth. So we let's say used or tested different models, empirical and also process one. And our colleagues at the Forestry Institute, they also recently published the one machine learning model. So they used the data from the NFI and used the random forest model for the basal area increment. So in our project, this LIFE ClimatePath, we decided to use the carbon budget model, which was developed in Canada, actually in 19th, first for the operational purposes, and then later the model was developed also for the accounting, and it's well described in the Kurz. Werner Kurz is the first author, and in 2009. And of course the problem was that basically this model was meant for the even age stands, and of course the input data are based on the forest on the stand age, which is not the case in Slovenia, because nowadays of course uneven age forest prevail. So that's why we have to do certain work, and of course I will speak about later. So here you can see the basic structure of the carbon budget model. So what are the required data? So the basic forest inventory data, such as the stands, area, growing stock, species compositions, and so on. of course, the core module of the model is the growth curves module. Then we have to define some modeling categories, and we can define, of course, the different disturbance types and transition rules. So the input data are imported through the carbon budget standard import tool. You have to fill 7 different metrics. You can see it below. So this is the basic. So what was our modeling approach, or what was work done in the project? So of course, as I said, we have uneven age forest stands in Slovenia. That's why we have to transport the input data, which was from the Slovenia Forest Service, and reclassifies this forest department into forest types. I will show which types we define. And also we have to transform our DBH data into age classes. And of course, we have to develop this growth curves for these 15 forest types. We also include the updated archive index database parameters. This was updated by the GRC. And then, of course, we have to prepare the input data, and then I will also speak about the model calibration. So we took the database of Slovenia Forest Service and reclassified all data to these 15 forest types. You can see on the right. This was done according to the national classification according to Kutnar et al. And yes, this was the first part. Then, of course, we have to transform the DGH data to H classes, as I said, which was quite tough. Of course, we done this with the comparing data to the past. So we calculate the diameter increment. And of course, there is also a difficulty that you have to assess, let's say, the first part until the tree is 10 centimeters in diameter. So this period we really attribute, I think, to 30 years. But of course, it can really depends on tree species. Can be 20, 30, 40. You know, let's say silver fir can wait for even longer time. But this was our assumption, of course. Then one huge work was done by the biotechnical faculty, by the colleague Mitja Klopčić, who helped us to develop the growth curves for these 15 forest types. And also our colleague at the Slovenian Forestry Institute, Jernej Jošnak, who is of course the co-author of this work, also transfer this growth curves into the model, and that, of course, these things works. Then, as I said, we incorporate the updated parameters according to EU archive index database, because of course original are from Canada and also tree species and so on. Then about the input data was, as I said, from Slovenian Forest Inventory database from 2014, and also we also used the harvest data from 2005 to 2014 in order to make a regression and to define the future harvest, because we have to make assumption about harvest for this modeling. And about the calibration, okay, it's not really, let's say, traditional calibration of the model, because we would have to do in different way, but nevertheless we adjust this increment harvest ratio. We fine-tune the distribution of harvest between different forest types, and also we adjust so how much thinnings and how much of final fellings. So you have to define this in the disturbance matrix. About the results, so we use these results for the LULUCF sector until 2030. So in the National Climate and Energy Plan. So here, if you on the left side, you can see in that time that we have the huge amount of natural disturbance which occurred since 2014, where in Slovenia there was ice slit, and after that there was also outbreak of bark beetles. That's why our sink significantly declines in the period, I would say until 2018 or 19. But now we expect that the sink will increase again. Of course, it depends how much the harvest will be realized in Slovenia. Of course, there can be also additional measures which can help to increase the sink. You have to also be aware that this is not only the forest land curve; it also includes the other sink from, let's say, from grassland, and also some portion from the harvested wood products. This was done projection for the long-term strategy in 2050. Of course, this is even longer projection. So for 30 years, of course, uncertainty can be even higher. But we expect that if the forest management will not be changed significantly, that even in 2050 we can expect around 2,000 to 3,000 kilotons of CO2 sink, of course, in the whole LULUCF sector. Here, of course, this is an ambitious scenario, so it means that, as Roberto emphasized, it depends how country will also, let's say, invest in wood processing industry, let's say the use of wood in building sector and so on. So there is, of course, a potential also in Slovenia, but of course in other parts of sectors there have to be investment, of course. And these are results which we published in the journal Forests recently. So different projection according to 5 different scenarios. So business as usual, more frequent natural hazards, then low and high harvest scenario, and also what would happen if only the forest management plans are realized, of course, in 100%, because in Slovenia 80% of forests are private owned. That means, of course, we don't have, I mean, strong instruments that we would force forest owners to make forest management more active, and that make the desertification of the allowable cut according to forest management plans realized. Yes. And these are the sink projections according to these 5 scenarios. So, of course, we assume that the harvesting level should be increased in order to regenerate forests appropriately, because we notice in some parts of regions the forests are getting older. Another problem is, of course, because Slovenia is quite hilly country with slopes, some areas are still not opened enough, and this is another problem. There is also potential to cut more, so we'll see what will happen. And about the perspectives, here I just listed a few factors which on which perspectives depends. So it will depend about availability of data. As Thomas showed us, NFI is probably the most important input for the modeling, probably in every country. But of course, in the LULUCF sector, because of the mandatory accounting, also now other land categories will be important. Capacities, of course, for the modeling, you need people, you need knowledge. So, as I said, in Slovenia, we started with this modeling maybe 5 to 10 years ago. So we are actually at the beginning, and that's why it's important that also in faculty programs, professors include those contents into their programs and encourage young people to start modeling. Models, of course, models, we can use old models or make new models. So just I wanted to say that there will be probably need to update the models. As Thomas showed us, of course, in the long perspectives, the climate will be important, and that's why basic empirical model without the climate node will be probably useless. So let's say for 50 or 100 years projection. That's why I listed also time frames. So if we model for 10, 20 years, the uncertainty can be lower, but if we project for 100 years, of course, we have to take into account the climate change, the breakthrough of new technologies, and so on. And also, I listed decision makers. They are actually the users of our results. So they use the projections for their decisions, for strategies, and also they have to listen the experts and try to be helpful in financing also researchers in the future. So, as this is the final conference, I would like to say a big thank you for the Institute Jožef Stefan team, so for our project leader Andrea Urbancic, who make really good job during these few years, also for other colleagues. Also, I would like to thank you to Slovenian Forestry team and others who helped us in this project, and also, of course, to financiers, to Ministry of the Environment and Special Planning, and to European Commission. So, thank you.
Yeah, thank you, Boštjan, for your presentation. So, are there any questions in the room? Is there anybody from the Zoom team? I don't see questions. So yeah, I'm from the same institution as you are, so I could agree with your final conclusions. Yeah, maybe a question about your modeling and results of the use of forest carbon with CBM CFS free model. So you have different kind of scenarios. So what are the difference between high and low harvesting scenarios?
Of course, we here assume that, let's say, in the low harvest scenario, the harvest would be around the 50% of the increment. So you can see that, let's say, in 2050, the sink would be around a bit more than 4,000 kilotons or gigatons of CO2 sink. While in high harvest scenario, you can see that, okay, here we assume that the harvest level will be, I think, close to the increment, or I think something more than 90%. And here, of course, here we didn't take into account any natural disturbances. This is included in the hazard scenario, and in these two scenarios you can see that in certain years, of course, there is no sink anymore, but we come to the emission side, which is quite normal. So here in the hazard scenario, we assume that every 5 or 6 years some natural disturbance can come, and also a few years after there is usually some disturbance due to bark beetles.
Yeah, thank you for now. So I would like to thank to all three speakers. And what we could do is to take a break, and exactly at 11 o'clock we will start with roundtable. So I invited all participants here and the online participants to participate at round table, and thank you for now. štartamo? Lahko. Okay. Hi to everybody. Now we will start with roundtable, the challenge of modeling and analysis of the carbon neutral pathway in the LULUCF sector. I will ask Roberto, Thomas and Boštjan to be with us. And but first, our colleague Gal, we will start with Mentimeter.
Hello,
Okay.
Hello everybody. So to get your attention after the coffee break and to just get some information that our roundtable would be more efficient, more focused, we would like you to participate in this Mentimeter research. You got instruction how to start it in chat. So you go to www.menti.com and then use the code 445-4140 and just answer the question. The first one, we would like to know of which group you are participate. So we would now that later we would could certificate your answers. As I know, it's around 40-50 active participants in Zoom, so we will wait a little longer. For now on, we have 13 people who answered the question. So with 20 people answered, the half of participants are from research organization, 1/4 from ministry, and 10% of government agency, NGO, and private company each. Oh, we still get some answers, so we will wait maybe 2 more minutes and then we will go to another question. Well, as the number stabilized at 23, we can go on. So the next question is: are you using models for LULUCF reporting? We will wait for 3 more people to answer and then we will go on, but now it looks like that 2/3 of participants doesn't use models for LULUCF reporting, so it's a big challenge in the future to use the models. Okay, we will proceed to next question. My experiences with using models at LULUCF are, so as we got only one question that answer on this, but maybe other people could also answer in the way why you did not use the models for your reporting. Okay, as far all experience with models were positive, so that's a good perspective in the future for using the models. Let's go on the next question. Here I would like that you put down 3 most important challenges for the future modeling in the LULUCF sector. So just words that cross your mind would be great. So as far data is in the center and assumption, so let's wait which word is coming to the center. That means if the data is in the center, that's got many answers. Okay, so we have like climate change data, good data, input data, available data, and after 2015, climate condition, harmonization, improved capacities. I think that's good information for us for roundtable. And let's go to the next question. Just please rank the challenges in LULUCF modeling. So on the first place is data collection, then preparation of models, and on the last place is calibration of models. We will move on our last question. How to ensure wider, better, and easier use of analytical and modeling results in policy making. So here is also, you can put three words, three options. So as far we have data, open data, data harmonization, knowledge, education, popularization, cooperation. Dissemination, participation, education. Okay, so let's here are really interesting answers: cooperation, knowledge, education, open data, dissemination. I think that that's good base for the round table. So thank you for participation in Mentimeter, and I will give my word to Primož. Thank you.
Yeah, Gal, thank you for your Mentimeter questionnaire, and we just warm up the place and us with these results. So we will proceed with roundtable. Here we prepare questions. So I put them on the screen just to see. Okay. Zoom again. Yeah. Okay. I put on the screen the next challenges of modeling and analysis of the carbon neutral pathway in the LULUCF sector. So we have here 4 questions with some additional questions. So, and I will read all 4, and then we will start with first one. So first is experiences gained through the use of LULUCF models. How can be used and integrated in your future work? And I will ask then Robert, Thomas, and Boštjan about your opinion about that. And then next question is challenges of the data collection, preparation, and calibration of models. What do you find most challenging and why? Then the third question is how can new challenges be addressed through new modeling approaches and analyses? Why are new modeling approaches needed? And the fourth, last question for now is how to ensure broader, better and easier use of analysis and modeling results in policy making. So, of course, we will be also happy if somebody in the room or on the Zoom also send us or ask the panelists with additional questions. So, start with first one. So, experience gained through the use of LULUCF models, how can be used and integrated in future work? Maybe Roberto, if you could answer on this first question.
Thanks for interesting question, even for the, let's say, the roundtable, these preliminary roundtables that we have between participants was also interesting. So I can, of course, just bring up my own experience that is linked mostly on this forest modeling linked to the LULUCF sector, mostly JRC, where we started to use these models about 10 years ago, and was I have to say was first part of our experience was challenging to see how to apply a model that can be easily integrated within different European countries. So it is challenging for me. The first aspect that we have to consider that we need to have, let's say, as much as possible some flexible tool that can be adapted to different situations. What we already told. So be flexible means not only in terms of input data, so having tools that can be used in front of different data available, but also in front of different time frames, and including as much as possible information coming from different expertise. So from colleagues working on economic models, with economic models, on colleagues collecting data from NFI, and so on. This is, let's say, my experience. Of course, was as I told you at the beginning, was quite difficult. But then, of course, once you are more confident on your tool, makes it more easy. And it is also important the collaboration with the other colleagues working also in other institutions, having maybe similar experiences, so comparing results. To understand why maybe we have different results. This is essential, I would say, in our work. So having different results, as I was trying also to show within my presentation, doesn't mean that one of the two, let's say, model is wrong and the other one is correct, but maybe simply due to different input data, different assumptions. So understanding why these assumptions are different, because we are speaking about let's say a modeling framework that is itself quite uncertain, and so that's also challenging, but also the part more interesting part, and why that's also the reason why we need, I think, to collaborate even more in the future between different institutions, even working maybe at different, let's say, spatial scale. So collaborating with the institution that may work at local level. I'm thinking to forest managers at national and regional level, and even at the EU level. So this can improve a lot our work and our results.
Yeah, thank you. Maybe Thomas, what is your opinion about can we use and integrate it in our future work? You already did, but yeah.
Yes, that's the point. From the if we are talking about forest growth modeling, I've been concerned for about 20 years with this topic. But as Roberto said, we have to collaborate with colleagues from other sectors. As I mentioned, for the LULUCF estimations, it's important also to cover the wood products modeling and this modeling with life cycle analysis and so on. And this is the important topics which cannot be covered by forest growth modelers, by myself. So we are focusing on having future collaboration with our colleagues from Boku University and also the Environmental Agency. So this collaboration must be extended, and then I think it is it will stay as or will be in the future a good tool to cover all these tasks that come from LULUCF reporting.
Yeah, thank you, Thomas. Boštjan, what is your opinion about?
Yes, I sure agree with both of them. The collaboration is important. Let's say when you are developing different scenarios, you have to make certain assumption about, let's say, different things. And for example, Caldi's model, as Thomas show us, it includes the climate data. So you have to know what, or you have to make assumption what the climate will go in which direction. Then of course it also includes the YASO, so you have to collaborate with the people working with soils. So yes, I agree with this 100%. About the CBM, I think we can use it also in our future work. There are still room for improvements, let's say for better calibration, even more. And of course, why this with CBM would be integrated in my future work? Because of course traditionally NFI are periodically monitoring. I mean, the data are coming partly, or let's say every 5 years when the cycle is finished. That means in this in between years, you of course you can make some extrapolation. You can rely on other data sources, or you can use models. So yeah, that would be my answer.
Thank you, Boštjan. If somebody from the audience want to add something or to ask sub-question, please. Here not. Okay, I'm looking in the chat and the audience. Yeah. So maybe we could conclude with this first question. So yeah, there is a need for collaboration. There is a need for comparison. There is a need to use LULUCF models. But as we saw in your presentation, Roberto, there are really at least 6 components or different kind of models, approaches to have this final or never final idea about future LULUCF sector. So what does our planet past tell us about its future? So when we are learning from past, then but we are now in new situation, so it's hard also for modelers to predict how the planet will behave or nature will behave in new situation, in new climate change environment. So for me, it was interesting just this year in Canada about this turbulent weather events, which the meteorologists could not predict because they never faced with such situation. And we are also facing in nature environment, in forest, with new situations. And we could not learn from past, but we could act from now. And so this is for me a theoretical, let's say, question. So anyway, The second question, challenges of data collection, preparing and calibration of models. So why do you find most challenging? Why? So maybe I will start with Thomas now and then with other from the round table. So
yeah, data collection is of course one of the most important thing. We in Austria, we are in a lucky situation that we have national forest inventory data for such a long time. But I know that many countries are lacking of such data. But not only the data is important. As I said, our model, for example, is an empirical growth model. So we have always we only can calibrate the relationships from past situations. And now in Austria, if I may give this as an example, we are facing a situation that we had in the northeastern part of Austria, huge calamities caused by bark beetles, which were actually caused by this dry stress by dry years. Yeah, almost all of Norway spruce died. And although we have a disturbance model in our CALDIS system, this does not cover these extreme values. And this is the same situation as you mentioned with the meteorologists from Canada. Predicting extreme values is rather tricky, and I'm not sure if it is possible at all. But on the other hand, now this emphasizes, because in Austria we have now in this fall the next inventory period will be finished, so we have another data set, and this should cover such extreme weather situations. And so it's important always to keep up with model development and data availability. In our case, these data will be available from next year, and so we are planning to reparameterize some of the modules, especially this disturbance model, that we can also cover these situations. But anyhow, it's always we don't really know which is what will be really the future regarding climate. But we are foresters, and we have to rely on the climate projections that are available. So this from my point of view, this keeping up with model development is one of the most important issues in this context.
Yeah, thank you, Thomas. Roberto, what do you think about it?
Apart from the fact that I fully agree with the Thomas, as Thomas told, yes, Austria is, let's say, a good example situation where data are, let's say, consistently and continuously collected in time. But the LULUCF, let's say, regulation, since we are speaking about a problem that is, as we are speaking about climate change and forest, that is a global problem, and this let's say, issue is faced at European level, overall at European level. The first, let's say, problem that we need to face is the data collection. So this means that we need to harmonize as much as possible this data collection, this availability of data between different countries. Since we have to face this problem collectively, I would say at European level, we need at least to start with the same base of information. So aligning to, let's say, the availability of data that we have, for example, in Austria, also other countries. Unfortunately, we cannot cover the lack of data that we had for the past for many countries. I'm thinking to Italy, since I'm Italian, but also for many other countries where we have this lack of data for the past. But as much as possible, we need to provide data at least for the present and for the future. So harmonizing this information, this collection of information between different countries will provide us, country by countries and overall at European level, with the same basis of information that is needed if we want, let's say, to find the best solution overall at European level, but as I already told, scaling the different solution at country level. This is, let's say, the preliminary, the minimum, let's say, requirements that we have to satisfy for the future. So the first essential point is data collection. And then, of course, as Thomas told, we need to face these new challenges that are linked to natural disturbances. So probably urgently developing new tools that help us to understand the possible impact of this disturbance event. This is something that is still, let's say, new, at least for us in Europe. It is true that we had big windstorms in the past, but these are coming more frequent, even because of the effect of bark beetle attack. So again, integrating different tools, different information, the experience that now we see in Austria, or I'm thinking also to Czech Republic regarding the correlation between windstorm and bark beetle attack, for sure will be useful, for example, in Italy or in other countries that did not experience the same in the past. But very recently in Italy, we had, I would say, the biggest windstorm that was never occurring in Italian forest. And for sure, we are not prepared, both from a management point of view and from a modeling point of view, to face this kind of event. So we may take advantage of the experience of other countries. So data collection is the first point, and the second point, of course, is having this tool, integrating new tools, and then calibrating these models. That is quite, unfortunately, quite time-spending stage, never finished stage, very frustrating stage, because all modelers know that calibrating a model is always frustrating, let's say, because it's never finished work. But at the end, this is, let's say, essential if we want to simulate different scenarios. Yeah.
Yeah. I could say I agree with you. So we have experience with ice sleet in 2014, and after that we have a huge few years of bark beetle attacks, and we never thought that the before very stable forests were so weak, and that we have such problems which we have now also. So yeah, you Thomas, you put your hand up.
No, I just wanted to support what
Okay,
Robert
yeah.
said. From a modeling point of view, a model is never finished, and you are always have ideas how to make it better. But if I may add some point, international collaboration would be really helpful, because here, if we can combine this data, then we maybe can develop models or submodels that can be calibrated from situations that are observed in another country, but and cannot be observed here in our country, for example, but will be the same situation in the future. So this could be a really good thing for the future to enhance this international collaboration.
Yeah, I totally support. So also for new forest strategy support us, and we hope that through the programs, EU programs, we could find a solution also for few projects for international cooperation with help of EU. So Boštjan, please.
Well, from Slovenian perspective, of course, the biggest challenge is data collection. As we know, the statistical-based national forest inventory started in 2000, and of course, this inventory is based on the 4x4 kilometer grid. That means on the country level, we have only 750 plots, which for modeling is not really so much. But now the new inventory will be a better solution. So 2 by 2 kilometers. So after the cycle is finished, there will be around 3,000 plots, which will be more data. And another thing is also different models, of course, require also different input data. That means not only DBH and the tree height, but also, let's say, I don't know, the crown length is important, and also maybe some other variables. Yes. But of course, I agree with what Thomas and Roberto said.
Do you have any comments here in the room or in the audience? I'm just following. If not, then we will go to the next question. So the third question is, how can new challenges be addressed through new modeling approaches and analyses? Why are new modeling approaches needed? We already answered partly on this, but if there are any new or additional thoughts about that, please, Roberto, if you could elaborate.
Yes, we already, let's say, touched this point. I just wanted to add that why we need this, let's say, a further effort as forester. I'm a forester, so when I was at university, I never touched these problems, and that's why also I appreciated one of the points raised from Boštjan in his presentation when he mentioned the need to including, let's say, modeling somehow even in within the forest studies. But why we need them? Because traditionally we, as foresters, we plan the development of our forest based on the past experience. So of course we are aware of the need to plan our forest management for the future to maintain our current growth capacity and so on, the multifunctional rule of forest and so on. But now this is what also Thomas was highlighting. We cannot simply base our projections, our planning on the past, but we need to be, let's say, more flexible to face something that is changing because of climate change and because of many other implications. I'm not just thinking to the effect on temperature or I don't know, CO2 fertilization, but other implications related to bark beetle attacks, the increasing frequencies of natural disturbances. So this is the reason why we need to develop new tools. We cannot simply base our work on, let's say, the traditional forest management plan that is for sure will continue to be useful, but even these tools probably needed to be more flexible, because I can have a very good planning my utilization for the next 10 years, and then I have a natural disturbance that is occurring within my region, and I need to react probably in 1 year. So I was thinking probably also our, let's say, models need to already provide some instrument to concretely help forest modelers. So for example, some prototype of possible reaction when I have, I don't know, a windstorm or a bark beetle attack, just to provide policymakers and forest managers with useful information. So what if I don't know, I remove 100% of the biomass that was affected by bark beetle, or what if I remove just 50%, or I will not remove this biomass, just to have an idea and helping really our policymakers and our forest managers to react, because we need to be ready to react. We know when we have a natural disturbances, we need to react in maximum 1 year, otherwise it's too late. So that's, let's say, a reason why we need to develop new tool.
Thank you. Thank you. So, and what's your opinion, Thomas, about that?
Yeah, developing new tools is, as I said, if a modeler is always not satisfied with his model, so new tools are very important. But it's maybe I may add another example. So we made some simulations and assumed a new tree, for example, a new genetically improved tree species, which has a higher growth than the traditional or the former tree species. But we can do this with new growth functions. But maybe we have no idea how this will interact with disturbance. So faster growing tree species can also have higher susceptibility to climate change or bark beetles or so on. And so if you have added one new component, like a new growth functions for a species, you need to have all, or you need to know how they react in the other components, yeah? And so this is always a challenging task, these new growth models. We know we foresters, as Roberto mentioned, we rely on past observations, and we are doing our best to keep up with the model development, but it's not always that simple. That it is meant by some colleagues, yeah. So I don't really know what to say in this context, but yeah.
Maybe I'm not sure, but we already follow Roberto articles when he was modeling the mixed forest, so broadleaves, and this was for certain period there were models more orientated to monocultures. And then the next question was how to put together the mixed forest and the different kind of, and you say a new species. This is also a challenge, how to develop such kind of models. So for me personally, so Boštjan, what is, let's say, what do you think? What are the challenges in new modeling approaches?
Yes, I agree that the results coming from a certain model can be further used. Let's say the one example are let's say the amount for the harvesting wood products. Of course, it depends on our assumption again, and also on external factors such as climate change. So personally, I think that in the future, at least climate will be incorporated in the new models, probably more than in the past.
Is there any additional question or comment from the audience? I just try to see. Yeah, our audience is quiet today. So we will now we'll try to find answer on the last question, which is from my point also a very important question, and it is it's how to ensure broader, better, and easier use of analyses and modeling results in policy making. How to improve enhanced transfer of knowledge. So my question, sub-question is also to who should we address with our results? We talk today about foresters, forest managers, about politicians, but I think important is that our knowledge we should share with the forest owners, with public, because the public opinion also is important, one of the most important to have a policy to reach climate neutrality. So, yeah, to ensure broader, better and easier use of analysis and modeling results in policy making. Roberto, please.
This is quite difficult question, honestly, I have to say. Well, I think we have to let's say, to distinguish different levels. From one side, let's say, if we strictly speak as a, let's say, as a modeler, so we will have as modelers our scientific results, and this will be delivered, I think, through, I don't know, scientific publications and so on. So this is, let's say, one level. Once we apply our models to forests, then we have at least our 2 or 3 different, let's say, level of communication. So we have these scientific results that are there, and the results will not change depending from the audience, let's say, from of our results. Then we have policymakers and foresters that are also important. So policymakers will take advantage of our results, first of all, if we are able to correctly communicate these results. Otherwise, there is a sort of cherry picking, you know? Taking just part of your results and not the other, depending from, let's say, personal attitude or, I don't know, other reasons. So it is important to be transparent when communicating our results and, let's say, in a complete way, and also sometimes also correcting some possible misinterpretation that can be due to, let's say, simply to the fact that, of course, policymakers are not experts of modeling or of forest. Then it's important, as you told them, for me, it's quite an important aspect to be also as much as possible, let's say, concrete, so to provide some useful information also for forest managers, because otherwise the risk that I see is that let's say we work and we live in a completely separate world compared with the reality. No, sometimes I have the impression that we live in our modeling world without taking care about how life is going within the forest system. So trying to have always these connections with the forest managers, with let's say, people really working in the field. I feel this as an important aspect, probably for my background, because I'm a forester, and before, let's say, start working with models, I was working in the field, first of all, as a forest manager. So this is another aspect. So somehow I understand this is quite difficult. We need to keep, let's say, connections between these different levels, and often I feel that we may receive some pressure as forest modelers from one side or from the other side. We are, let's say, in the middle, and it is important that we are able to communicate both, let's say, the upper side, let me say so, to policymakers, but also on the other side to forest managers, and we have the big opportunity of take advantage of information from both these aspects, even if, as I say, it is not easy. That's my impression, my personal opinion. I'm happy also to hear from.
Thank you, Robert. So, Thomas, what is your opinion about this question?
Yes, I agree with Roberto that all these results should be transparent and should be in a way that that everything is okay. But if you're talking to politicians, then you need to present very concise results, because they do not read long reports. You need some concise results, short results, but the most important results. So, and this is one of the challenge. I know it is not so easy always to transfer this to the political sector, but on the other hand, sometimes I think that you must really put more or less provocative assumptions also on the agenda, that politicians wake up. Because if I read some programs where they say that they want to maintain the forest sink forever, then I must say as a modeler, this is not possible. And if, at least not if the forest area is unchanged, yeah, because the development of forests reaches in some way its saturation point, and then you have a decrease in this growing stock. And this is just a very short point, but an important point, and I'm not sure if our politicians are always aware of that. And so this can be shown in a very simple way. That's what I meant, to be very concise and provocative in a way, but these long reports are not read. Yeah, as Roberto also said, it's a very tough question. So from my perspective, we should enhance this talk, or should enhance talking to politicians, but really simple and the most important issues. Because, for example, in Austria, we also found in our study that if we continue harvesting like we did in the past, this is not an optimal way. We could change the forest management in Austria so that this forest sink is maintained for a longer time than I have shown now. But anyhow, it cannot be maintained forever. This is not possible. But I'm not sure if our politicians are interested in that, because on the other hand, it would be very good information for them, because they could maybe transfer the subsidies in a way that this forest management is changed in that way, that we maintain our forest sink for a longer time than if it is maintained in a business as usual scenario.
Yeah. Thank you. Yeah, it's a short term for politicians and long term for foresters and owners.
Yeah.
So, Boštjan.
Yes, I agree. It's a tough question. Yes, maybe we can rely on also what participants said, that of course the cooperation is important. Of course, it is also important that, let's say, the policy makers who are the users of the projections or modeling results also have a capacity to understand these results, so that they have a good background knowledge, so that they can really understand what these projections means. That's why I think it's also important for the smooth transfer of this knowledge or results from the, let's say, people who are working on modeling to those people who are actually then important for the policy and I mean at the strategical level.
Yeah. Is there any from the room or from the Zoom application? Is there any? Are there any questions? I'm just checking. Do you see somebody? Ucetu? Okay. Yeah. There is one opinion in chat. So one of the most important considerations that emerges from the models is that the choice of the management strategies is one of the most important factors affecting the carbon sink. So in Europe, many forests are privately owned. Yeah. In my opinion, an important message from forest modelers to policymakers would be the importance of getting passive forest owners to manage their forest. This is especially important for countries with a large proportion of private forest owners. What's your opinion about this comment? Maybe Roberto.
Fully agree, absolutely. That's why I think we also need, let's say, to consider within our modeling framework some economic model or some, let's say, some model that can take care somehow of the possible reaction, I would say, of forest owners in front of some economic incentive or some of possible, let's say, economic drivers. So it is not easy, because as far as I know, there were many experiences in different countries trying to, let's say, having some reaction from these passive private forest owners, but they were, in many cases, they did not have success. But for the future, even more now, of course, if we want to have some, let's say, to change this trend, for sure, we will need to have some measure. I have an idea which one, because I'm not, let's say, I don't have an economic background, but to put in place some measure that can help, or at least, yes, move these owners towards another directions. But yeah, I fully agree.
Yeah, maybe Thomas, do you have some? I would say, because we are at the end of this roundtable, also comment on this comment, and if you have some last comment for today's roundtable.
Yes, a comment on the comment from Mitja. I know Mitja very well because we are collaborating right now in an EU project, and his point is very important for Austria, because in Austria, forests are about 85% of forests are privately owned, and we are facing this problem, especially because most of these privately owned forests are owned by forest owners which do not have more than 5 hectares, and so this is a big issue to motivate them for more or less professional forest management. And we are also facing more and more forest owners who are not even interested in forest management. For example, these are people who are lawyers or physicists living in big cities, and they do not even know that they are forest owners. And how to address them, this is a very important topic, but the topic that in Austria policy is they are aware of this problem, and they tried several projects to get these forest owners doing a professional forest management, but it's not so easy. So the only thing that I can say is it's important that we are aware of this point in Austria, but it's not so easy to motivate the forest owners.
Yeah, I agree. So, Boštjan?
Yes, I agree. With for those countries who have forests in private ownership, for sure, this is important. What Mitja have said. Now, of course, is the question how, with which instruments we would motivate forest owners that they would like to manage their forest more actively. Of course, incentives are one way, but on the other hand, in the past, this rural development program, we also saw that sometimes even there are appropriate instruments, people are still not willing to submit and to take this opportunity. So I don't know what approach would be the best one.
Yeah. So at this point, I suggest that we stop our roundtable. If there is any question from the audience, but I don't see it, or comment. So I suggest to finalize, and please, I ask all three for one last sentence, a key message from today's roundtable. And I also thank you, both three speakers, for very interesting presentations, that you open very interesting tasks, and that you were willing to participate the whole half day with us, also within roundtable. So please, for one sentence, and then we will finalize our roundtable. Yeah, please, Roberto.
First of all, thanks a lot for this because it was really quite interesting for me. And I would, have to summarize what we discussed. I think that one key word would be collaboration. So collaboration between different institutions, between modelers, but not only, also between, different models and different stakeholders. So clearly we need to work all together, not only within our field as foresters, but also collaborating with other experts from economic, from, GIS. So that's essential, because otherwise, as we saw, it's really challenging, and we will not able to answer to these questions. So that's my key message. Thanks again.
Thank you. Yeah, Thomas.
Yes, all the most important things are said by Roberto. I just want to add one statement, which means combining national forest inventory data and growth models is a promising tool in the LULUCF sector.
Thanks, Boštjan.
I totally agree. The NFI will be still the major input for the models. However, I also see some opportunities to improve, data, and also modeling of also for, grasslands, especially because our grasslands have certain part covered by woody vegetation. So these are more or less abandoned agriculture grasslands, or some these lines along the waters. So Slovenia has really a lot of woody vegetation, and of course with this traditional approaches such as inventory, which we know is the time-consuming. It needs finances and resources. Probably in the future we will more rely also on other techniques and methods, such as remote sensing. I also know, because I spoke 1 year ago with the colleagues who is working at the European Environment Agency, that the Centennial resolution so the satellite images will improve. So we can expect that, let's say, some kind of semi-products will be available in future years. And as we said during this conference today, merging this, so ground measurements and remote sensing probably will give us improved results in the near future. Also for maybe also for reporting purposes. Thank you.
Yeah, with this we will finish with our roundtable. There are, of course, new questions. We raised new one, and but we answered on few of them. So thank you again. And there was a wish from the main organizer, Andrea from Jožef Stefan Institute, that we announce also the end of the conference, LIFE ClimatePath2050 International Conference, Designing Pathways Towards Climate Neutrality. I would like to thank you, the main organizers, the speakers, the technicians from Radio Student, and all who participate during the conference and make us this hybrid conference nice and easy. I hope so that you enjoy and that you hear interesting information about the topics during the conference. So we see we need strategies, and we need strategy especially for climate neutrality, how to reach it. And through 4 sessions we hear some basic ideas and good ideas and approaches. So we hope that process will not finish with the end of the project, but as always, life projects, they have afterlife, also activities, and I hope that we could join all the partners in the project and to work further in the next years. So I announce now it's end of conference, and have a nice weekend.